Well, good morning everybody and welcome to the Heritage Conservation as Environmental Conservation Symposium. My name's Justine Clark and I'm going to chair today's event, which has been organised by Robert Crawford, Senior Lecturer in Construction and Environmental Assessment in the Faculty of Architecture, Building and Planning here at the University of Melbourne. Robert has framed the event in terms of the overlaps and tensions between heritage and environmental concerns. He writes, "In recent times, it has been common to hear designers, environmental advocates and others declaiming against older buildings based on their poor environmental performance. At the same time, heritage advocates have embraced the idea of embodied energy and made bold claims on behalf of the environmental benefits of preserving older buildings rather than replacing them." So today's event aims to explore these seemingly contradictory perspectives, and of course we all know that it's much more complex than either of those sort of opposite straw men would suggest. So today is really aimed at generating and facilitating conversation between disciplines and approaches, and to discuss the principles and practices involved in assessing environmental building performance and the role that heritage buildings can play in protecting the environment. The symposium is part of a broader program of activities that have been organised under the New Prospects in Heritage and Conservation program, here again organised by the faculty at the University of Melbourne. And this program aims to establish much stronger links between academic research and heritage practice. The aim is to inform research with the ideas and perspectives gleaned from practitioners, while simultaneously sharing research findings and thinking in ways that one hopes can be picked up by practice. The group also hopes to give heritage a much bigger footprint in all of the disciplines and activities within the faculty, and to expose as many students as possible to basic questions and problems in heritage and conservation. So, expanding the kind of mandate for thinking about heritage beyond the heritage specialists, so that everybody is to some extent aware of the issues and understands how one might start to activate them. This program of activities began last year when Hannah Louie and Cameron Logan convened a national roundtable about heritage conservation education. This helped shape the curriculum for renewed postgraduate coursework programs here at the university, which have subsequently been developed by Philip Goad and Kate Darian-Smith. Last year, the New Prospects project also staged events and exhibitions about the heritage of modern educational buildings and campuses, and the heritage of the designed landscape in Australia. And this year, Amanda Ahmadi ran a major and very successful symposium on Asian architectural and urban heritage. So the New Prospects team hopes that today's event will continue to expand the discussion and create further connections between and among researchers and practitioners. And from my perspective, I think these kinds of discussions are really important. It's really vital that we bring together different disciplines and that we cross between academia, practice and policy. And this seems to me particularly fertile ground for the development of both new knowledge and new practice, so we can affect change in multiple ways. Today's symposium is organised into two sessions. The first presents a series of position papers which consider the question of environmental benefits and the opportunities of heritage conservation. And the second looks at a set of case studies. And at the end of the event, we'll have a panel discussion with everybody who's spoken. I hope that we'll also be able to open up to questions to the floor, but we'll sort of just have to see how time goes. But please, as you're listening to the presentations, do kind of start salting away questions and comments for that final conversation. We're going to try and keep to time, although we're slightly over already. And if there is time for questions at the end of a presentation, we will take them, but try and address those to be quite specific questions about the content of the presentation and save your kind of broader commentary or cross-paper discussion for that final panel. So, let's go to our first speaker, who is Dr. Robert Crawford. So, as I mentioned, I'm going to introduce you. Robert is a senior lecturer in the Faculty of Architecture, Building and Planning here at the University of Melbourne. He was an inaugural Future Fellow here and also worked as a senior researcher for Williams Bogue Architects. Robert specialises in assessing and improving the environmental performance of buildings in life cycle assessment and the quantification of embodied resources. His topic today is the embedded environmental value of heritage buildings. So welcome, Robert.
Thanks, Justine, and good morning, everyone. It's good to see everyone here. As Justine has said, I'm going to be talking about the value that is embedded in existing buildings in terms of the resource value. I'm going to be looking at the significance of that, how important it actually is, and also how we might actually go about quantifying it. What I propose to get across to you today is that the greatest opportunities for improving the environmental performance of the built environment actually exists in the conservation of our existing buildings. And this is in contrast to the focus that we typically take to our built environment, where we focus on improvements to the operational performance of our new buildings. One of the key benefits or key resources that are embodied in existing buildings is the energy. The energy that's gone into manufacturing the materials and the systems that are in our buildings. There's an increasing focus on talking about the embodied energy, or the energy that's embodied in our buildings. And for those of you that aren't aware of what embodied energy is, I've put a fairly simple definition up there. And it's basically the energy that's required by all the activities associated with the manufacturing and processes of materials and systems that go into our buildings, in the context of buildings, of course. But also the energy that goes into making the equipment required to manufacture materials and all of the other services required to get buildings up and usable. There's an increasing focus and discussion around embodied energy, as many of you will be aware. Even in things like Green Star, there's increasing talk about credits for reductions in embodied energy and so forth. Yet, still broadly in terms of the industry, it's rarely considered in most of our projects. It's really not discussed or included as a component of the design or refurbishment of our buildings. And one of the reasons for this is because it's considered to be a fairly insignificant component of the energy associated with a building over its life. Okay? Most people suggest that it represents maybe 10 to 20% of the total energy required for a building over its life, and therefore we don't tend to focus on it a terrible amount. And that's why we tend to focus on the operational efficiency, improving the operational energy efficiency of our buildings, because we're more aware of that, and we think that it represents a larger proportion of the energy associated with our buildings. We use a range of different passive and active strategies to deal with those efficiency issues and reducing the energy consumption in terms of the operation of our buildings. But there are two significant and often unthought about consequences associated with this. The first of those is the fact that by reducing the operational energy requirements of our buildings, we're increasing the proportion of the embodied energy component. Okay? Secondly, the energy efficiency solutions that we're integrating into our buildings, like innovative heating and cooling systems, high-performance glazing systems, increased insulation levels, what they're actually doing is increasing the amount of materials required in our buildings, and therefore increasing the embodied energy component as well. So there's actually two things working against us in terms of being able to reduce embodied energy as a result of the focus that we currently have on buildings in terms of improving their operational efficiency. This might not be a problem if the embodied energy component of our buildings was insignificant or relatively minor. But more and more research is showing that the embodied energy component is actually the most significant component of a building's life cycle energy requirement. This is a result of just one of the studies that I've done. I've got numerous examples, and there are other people that have got examples of this that show that if you combine the energy associated with the building's initial construction with the energy associated with replacing materials over a building's life, it can represent more than the operational energy requirement of our buildings. And as we're reducing the operational energy required in our buildings, that proportion is increasing, as I mentioned before. So it's an area of significant interest and increasing interest for us to focus on. Now, there's all this talk about embodied energy as the sort of the soul or the main focus of conserving our buildings and the reason why we should conserve our existing buildings. But we need to keep in mind that energy is not the only resource that's required to construct buildings. There's a whole range of other resources that we require. Water, other raw materials, and outputs associated with the construction of buildings such as waste and pollutants and other emissions like greenhouse emissions. These are all consequences of the construction of buildings, and we need to factor those in as well and consider those just as importantly as we do embodied energy in terms of embodied water, embodied materials, embodied waste and embodied emissions. So there's a significant advantage in conserving our existing buildings because there is such a huge amount of resources embodied in the materials that they're made up of. And that is made more clearly obvious by the fact that it is the components of our existing buildings that are most durable and the most easily conservable that actually represent the highest proportion of their embodied energy. So the main structure, for example, represents about 40% of the total embodied energy of a building. So if we can even strip a building right back to its main substructure and superstructure, we're still conserving potentially about 40% of its embodied resources. So if we're able to conserve all of this energy and all these resources by conserving our existing buildings, we're potentially already saving some embodied resources by not building a new building. We've got to also consider the fact that there may be particular limitations associated with our existing buildings that mean we're not able to achieve the operational efficiencies that might be possible with a new building in terms of glazing areas, external materials of existing buildings and things like that. And if we've got to balance the saving in embodied resources with a potential decrease in operational performance across the life of these buildings. So we need to determine or make sure that there's actually a net benefit being achieved by conserving our buildings. And there won't be a net benefit in every case. We've got accepted approaches for quantifying and modelling the operational performance of our buildings. But the modelling and quantification of the embodied resources of our buildings is much less developed and less understood. So there's a lot more work that needs to be done in that area in particular. So then how do we go about quantifying these resource savings, potential resource savings from the conservation of our existing buildings? Now that we know they are and they can be significant, the approach that we typically use in the field of life cycle assessment is embodied resource analysis. So if we're quantifying embodied energy, it's embodied energy analysis or embodied water analysis for water. A general term might be embodied resource analysis. So we can actually quantify the embodied resources that go into constructing or refurbishing a building. This approach comes under the general framework of life cycle assessment that many of you may have already heard of. The framework is outlined within the International Standards 14040 series, which basically sets out some guidelines for how to conduct a life cycle assessment, or as a streamlined form of life cycle assessment, an embodied resource analysis or embodied energy or water analysis. These types of analysis are based on material-specific resource coefficients. So, for example, in terms of embodied energy, we will have a quantity of energy that is required to produce a certain amount of material. So, gigajoules of energy are required to produce a cubic metre of concrete. And we can model the embodied resource of a building by determining the quantity of materials in each building. As a result of that, we get a sum of the total quantity of resources that have gone into manufacturing or producing a building, and also the outputs that are produced as a result of that in terms of waste, in terms of emissions. And as an aside to that, or a continuation of that, we can then look at the environmental impact associated with that, because energy isn't necessarily energy. Different forms of energy result in different environmental impacts. And we can use this life cycle assessment approach to quantify the global warming potential or the potential for resource depletion or other pollution that might result from the construction of our buildings. Now, the most common, or one way of actually quantifying the potential resource savings from the conservation of existing buildings is to model the resources that are embodied in those existing buildings. Now, the issue with that is that the resources that were required to construct existing buildings, potentially decades or centuries ago, is different than the quantity of resources that would be required to replace that building now, based on newer and different manufacturing processes, more efficient manufacturing processes potentially, different materials and different ways of construction. So that's not the most ideal way of quantifying the potential resource savings associated with conserving our existing buildings. The preferred approach is actually to look at the avoided resources associated with conserving and the continued use of our existing buildings. So what's the resources saved by not having to build a new building compared to keeping the existing building? In order to do that, we need to quantify the embodied resources in an alternative new building for the same function, a similar size and so forth. And I've just demonstrated how we might do that. From that, we need to subtract any additional embodied resources that might be required to make good the existing building. In most cases, there will be requirements, upgrades for the existing building to bring it in line, not only in terms of physical appearance, but also in terms of maybe structural integrity and other technological, functional, thermal, health and safety requirements to comply with our current expectations and also building regulations. So we need to subtract that from that potential resource saving by keeping our existing building. And as I mentioned before, there might also be additional operational resources required for an existing building compared to an alternative new building because of potential limitations on existing buildings in getting their operational efficiency up to what might be possible with a brand new building. So what I want to focus on now is some of the strategies for and things to think about when we're assessing the embodied resources in a new building, because that's important to understand when we're trying to quantify the savings that might be expected from the conservation of our existing buildings. So just to give you an idea of some general figures around how much energy is embodied in buildings, we're looking at around about 10 to 20 gigajoules per square metre for residential buildings, slightly more for commercial buildings, just because of greater structural requirements and servicing requirements in particular. To give you an idea what that equates to, gigajoules doesn't mean a lot to a lot of people. For a typical detached average size house in Australia these days, around 240 square metres, we're looking at around about 4,000 gigajoules of energy for one house. That's about the energy content of 500 barrels of oil, or the amount of energy required in fuel to drive around Australia 35 times. Okay, so a significant amount of energy in one house. We can also look at the embodied water of our buildings. From a residential point of view, you're looking at around, on average, 15 kilolitres of water per square metre. For commercial, a bit more again, for the reasons I mentioned before. To give you a better idea about how much water that is, you'd need to fill a building up between 5 to 10 times with water to equate to the embodied water in that building. That's before we even get to using the building and consuming water for operational purposes. And there's some general rules of thumb that we can think about when we're quantifying or assessing the embodied resources in our buildings, and also looking at strategies for minimising those resources. As I mentioned before, the building structure typically represents about 40% of the total embodied resources in the building. The construction process itself is typically less than 5% of the total embodied resources for a building. So trying to minimise energy consumption on site in terms of power tools and cranes and all that sort of stuff has little impact in terms of the total embodied resource requirement for a building. Road transportation, it's about 4 times more emissions intensive than shipping is. So in some cases, it may actually be more worthwhile from an environmental point of view to import materials from overseas than to obtain them locally, depending on the travel distances involved. However, saying that, transportation requirements associated with the embodied resource content of buildings is typically less than 5% of the total overall resource requirement. Okay, so it's not a significant area to focus on. And reusing and recycling materials is also a good strategy when it comes to minimising embodied resource content of buildings. You can save up to about 95% of the embodied resources associated with construction if you're reusing materials, and 90% with recycling materials, depending on the extent of making good and the source of those materials in terms of how much transportation energy might be required. So we're developing a greater understanding of the embodied resources in buildings and how to quantify them and also how to minimise them. But there's still some major challenges that remain. And one of the major challenges is in data, both in terms of access. It's extremely difficult to get access to quality data because manufacturers are often reluctant to release that data for various reasons. Data, by the time we get access to it, is often out of date and potentially decades old. And that doesn't necessarily relate to current practice and current production techniques for materials. The reliability and completeness of data is also an issue, in particular where we are not able to capture all of the resource requirements associated with manufacturing particular materials because it's too time-consuming and too complex. And so we tend to limit the scope of that data collection exercise to what we think is the most important processes in manufacturing particular materials. The geographic relevance is also a really critical one. Most of the tools available in Australia at the moment for quantifying embodied resources rely on overseas data. That overseas data doesn't necessarily reflect Australian production techniques and processes and the resource requirements associated with Australian produced materials. There are issues with assessment techniques in terms of their complexity, but also their limitations, and many of them are actually flawed. I won't go into that in detail at the moment. And the time and cost involved is also substantial in a lot of cases. It can be extremely time-consuming to conduct a full LCA or a full embodied resource analysis of a whole building, and also because of that can be quite costly. It can take months and months to do that. And it's not something that's going to be done on every single project. So in summary, what I've hopefully shown or got across to you today is that the embodied resource value in our buildings is significant, and a lot more significant than most of you probably already thought, and many people actually think it is. So therefore, maximising the value of these embodied resources is absolutely critical in terms of conserving the environment and protecting the environment and reducing the resource requirements that we have from the environment. We also need to take a whole-of-life approach, because it's no longer acceptable, and it's often misleading to focus on one aspect of a building's life cycle, such as the operational performance of a building. We need to factor in the embodied energy associated with buildings, but also the ongoing embodied energy associated with replacing materials over their life. Sometimes it might not actually be beneficial to conserve our buildings, particularly if there are significant operational efficiency reductions associated with those buildings, and not as a substantial reduction in embodied resource requirements because of the conservation of that building. This seminar is focused on heritage buildings, but I think the bigger discussion is around existing buildings, because heritage, particularly heritage listed buildings, represent only a small proportion of our building stock. And in a way, heritage listed buildings are much easier to deal with, because we're limited and often restricted in terms of keeping them as they are. So it's not as complex and a difficult decision to make as it is with all of our other existing buildings, that the decision to pull them down can come a lot easier, as a lot less controversial decision in a lot of cases. And so finally, I'd just like to say that we need ways also of identifying opportunities for minimising the embodied resources in our building stock, and particularly in our existing buildings, and strategies that are specific to existing buildings, not new buildings. Existing buildings have their own unique characteristics and a unique way of dealing with the reduction of environmental impact. And a number of our speakers through the rest of the day will be dealing with some of these issues in a bit more detail. So thank you.
So our next speaker is Noy Hildebrand. Noy is editor of the Australian Institute of Architects Environment Design Guide. She's a registered architect in the United States and a sustainability consultant who's trained in a range of systems: the Living Building Challenge, the Bioregional One Planet Sustainability, LEED and Green Star. Noy has worked on medium and large buildings in Australia and abroad, and her areas of expertise include high-performance building design and the interaction of facades with natural ventilation. Noy's topic today is heritage buildings and environmental response.
Good morning. Thank you for inviting me here today, Robert. And it's funny that I go after you, because my talk actually has to do with operational energy and the unique characteristics of heritage buildings. So yes, as Justine said, I edit the Environment Design Guide. EDGE is an online publication of the Australian Institute of Architects. EDGE has over 200 peer-reviewed design notes, which cover various aspects of sustainability in the built environment. And while some of the material can be a bit technical and theoretical, the target audience is primarily architects and designers of the built environment. Often research around building science and other aspects of built environment research isn't directed towards the people who would actually use the material. In this way, EDGE serves as a direct link between environmental design research and design practitioners. And more information can be found at the websites shown there. So now that that's been said, it is my hope today that the following case studies will make evident the sustainable design embedded within the heritage architecture presented. The remainder of the talk will be structured as follows. I will first cover the importance of existing buildings in general and heritage buildings in particular with regards to energy use and passive design, actually. Next, I will go through some warm-up case studies that will illustrate integrated passive design responses in architectural form. These will be the Cairo Flats in Melbourne, Agra Fort in Agra, India, and Red Fort in Delhi, India. Finally, I will introduce the main case study of this talk, the Dome Building at the State Library of Victoria, as an example of a heritage building that could probably benefit from a deeper reading of the 1913 original in terms of daylight, visual comfort, and occupant delight. I hope this presentation can spark an appreciation for the passive design in heritage buildings, that is, how heritage buildings perform or were meant to perform with regards to heating, cooling, and lighting. And I guess, as Justine said, we're going to try to save longer questions for the end, but if there are any clarifying questions, I don't think my presentation will go over. How can a building filter sun, heat, light, and air to support its users? How can these elements address different aspects for different functions? Heritage buildings are immensely embedded with knowledge about how to light, heat, and shelter spaces using the materials available on site. While cheap, abundant electricity has been available in Australia for quite some time now, the older cultures of building did not assume this to be the case. Why do our newer buildings, and even some heritage retrofits, seem to overlook the passive design wisdom of older buildings? How can we enhance this embedded wisdom looking forward? To provide some background context, I'll briefly touch upon heritage buildings and energy use. As you likely know, operating buildings takes up a very large part of the total energy produced. Apparently, according to Robert's presentation, not as much as I thought, but this presents a significant environmental impact. Since existing buildings are likely to be around for the foreseeable future, reducing their energy use can make a big impact on reducing our total energy use. Unlike new buildings, existing buildings have a performance track record. They have dealt with external environmental and human impacts of being occupied over time. Heritage buildings can have traces that describe how the architecture once performed, that is, how the building illuminated, ventilated, and sheltered with minimal input to suit the needs of its users. Heritage buildings have much to teach us, though not through both their successes and failures, about how to respond to climate and use in sometimes remarkable ways. How a building is used and adapted to be functional, comfortable, and delightful for its occupants can be evident if one knows what to look for and how to look. It is my hope that the following case studies from Melbourne and beyond can help with this. Just a quick aside that some of the material I'll talk about will seem like it's obvious. It won't be new to most. And in a way, it kind of is obvious. However, a lot of what is obvious can seem camouflaged amongst our routines and habits. So maybe come to it with that frame of mind. Though the case studies themselves are not earth-shattering, what they do is highlight work that architects don't seem to do anymore. So after I put these slides together, I realized I didn't bring the prettiest images of Cairo Flats, but oh well. So this is Cairo Flats in Melbourne, designed and built in the 1930s by Best Overend. These minimum flats with maximum comfort have very interesting openings that face the cantilevered corridors, which are those on the left. The front door of the apartments has sort of the splash guard detail, which was probably designed to keep rain out and away from the door sill. The next are the bathroom and kitchen windows, which, if I go back here, this is the kitchen window, and this is the bathroom window. They're both elevated so as to assist with privacy and security concerns. So the bathroom window has a lower part of the sash which allows for daylight but obscures for view and privacy, while the upper glazed louvers allow a view of the sky and sort of a moderate level of exhaust. And then the whole thing is mounted on a casement window sash, which can fully open for an even higher level of exhaust. The next one is a kitchen window, which again has that obscured pane with the upper level open for exhaust and, in some cases, for views out. Okay. The next mini case study is Agra Fort in India. In this particular building in the complex, the porous walls allow for breezes and daylight while mediating glare and view. This is a very hot, dry climate, so it's also a bit cave-like in order to keep some of that coolth over from nighttime hours. And this next example is Red Fort in Delhi, India, which is in some ways very similar to Agra Fort. It also has the sort of the screen walls in some locations. But in addition to that, the breezeways that the screen walls kind of allow for are coupled with shallow pools and a waterfall, which help with evaporative cooling in the hot, dry climate. So it's worth noting that the carved screens and the water features are integrated into the architecture. They provide pleasant aesthetic and a cooling function for these places. Okay, so the final case study is the dome building at the State Library of Victoria from 1906 to 1911 by Bates, Peebles, and Smart. As with buildings of this era, the dome reading room was designed and built at a time when architects designed buildings to harvest daylight and naturally ventilate. For this talk, I'll be focusing on the dome reading room in terms of daylight. How the light was brought in to be usable was a skill characteristic to the culture of architectural practice at that time. In much of the world, electricity was not always consistently available, as it seems to be in our own time, and daylight was a key reliable resource. Combustion-based lamps were available, but they create fumes, and fire and books don't really go together. This influenced how architects designed buildings and spaces. They had to make a concerted effort to light spaces for working, for reading, and for visual legibility. I guess, let me see. So these are the main three images that will describe this phase of the dome, so opening until they sheathe the roof in copper. So this is fully daylit. If you look at the lights, it's hard to tell sometimes if they're on or off, but you can tell if you compare those images with this one where the lights are clearly on for some sort of a manuscript display or something. As an exhibit about the dome building states, the 480 glass panes in the dome provided the room with sufficient daylight so that artificial lighting was only needed at night. Such is the case with, when the dome reading room was opened in 1913. Subsequently, though, the skylights developed leaks and required multiple repairs, and in 1959, the dome skylights were sheathed in copper to prevent water leakage. The reading room went under refurbishment again from 1999 to 2003, where the copper roofing was removed and replaced with skylights, with new skylights, including some higher performance glazing. An argument for uncovering the skylights was a connection to the outdoors. The lead architect did express this in one of his interviews. Today, the reading room uses both daylight and an abundance of electrical lighting throughout the day at all times of the year during operating hours. Sorry, this is from back when it was, the copper roof was covered, and this is today, but sometime between 2008 and 2013, according to Flickr. And as you can see, the daylight quality in there is nice. You don't really see much besides just a general luminance and maybe a little spot there, but all the electric lighting is on. So, let's see. So in this room with beautiful skylights, you have at least 4 kinds of lights that are always on. at least any time I've been there, and as much as I can gather from chatting with the librarians. At least the desk lamps at least are all on one switch and are turned on in the morning and turned on in the morning at opening and turned off in the evening when they close. So whether or not people are there, they're on. Not all of the lighting in there is original. I think the green desk lamps are either original or look like they're original, and the round pendants. But besides that, all the linear lighting along the desks and actually along the book stacks. You can kind of see a slight glow, I hope, along the book stacks here. And there you can see it much better. That is probably from both those linear fixtures, and those linear fixtures are most likely from the time when the dome was covered to compensate. So it seems that the lighting schedule post-skylight refurbishment was identical to that before when the skylights were covered. So why was this? Perhaps it didn't seem to be an issue since nothing obvious was broken. Thank you. While the reading room refurbishment of the early 2000s was designed to visually align with historic themes, it does not seem to perform with the original daylight virtues of its historic self in mind. The ingenuity of designing with daylight and capturing it for reading, thinking, and reflecting seems to have been lost in translation. So why is it important that the space be predominantly daylit? Well, for one thing, it's in keeping with the design intent. It's in keeping with the performance design intent of the original building, and shouldn't that be important for heritage? Improved daylighting can also reduce lighting energy use, which in non-residential buildings can be about a third. And that couples with our desire to improve sustainability, reduce energy, and all that good stuff. The third reason is that our eyes have evolved to the wavelengths of daylight. We have an older, more intrinsic biological connection with daylight and sunlight than we do with electrical lighting. Daylight has been connected with circadian rhythms and health. And the fourth reason is that the quality of light, I think, in the room is reduced as compared with the original. Though the current reading room appears to sparkle and warmly glow, partly due to color photography, something about the quality of light in the space seems somehow less cohesive, less connected. The ground in the space, and I feel like I should go back for this. So the ground in the space feels somehow less connected to the sky. The occupant seems less connected to the outside world. It's harder to sense where the sun is and what the sky is doing. The architectural space is performing more like any other big room that happens to have a skylight. Okay. Yep. This is not to say that the reading room should necessarily revert back to its 1913 lighting schedule. Electric lighting has its place, such as during heavily overcast skies, and at night, of course. The room with a skylight is no doubt a huge improvement to the room without, but if we truly value natural light, as we say we do, why do we persist in competing with it rather than working with it? I, for one, hope for a less energy-hungry dome reading room one day, where the daylight is sufficient for ambient illumination and reading, when conditions permit, and where electric lighting can be used when needed or desired, rather than by default as it is now. So I took some photographs of the reading room currently and the similar historic ones so that we can compare, and hopefully with the mouse. Okay, so this is the modern day reading room. Well, my mouse is upside down. And then this is the one from before the sort of the original. And you can see a couple differences. Well, first, the glass is different. So I think that the current glass has a more diffuse pattern, or it's more diffuse, let's just say that. The light fixtures from the time when the reading room was covered in copper are all still on. And you can see in the original that these pendants are actually not on, but in both of the newer images, they're on. The only time I've seen them off actually is when one was, I think, needed to be changed. The other thing I noticed about these images is that in the older images, a lot more of the occupants seem to be seated, sort of leaning back, whereas in some of the newer images, a lot more are hunched forward, kind of more introverted, or, I don't know, self-contained or something. But yeah, I just thought it would be interesting. Okay, so in the context of energy use in heritage buildings, what do these case studies have in common? Well, for starters, these examples of architecture include design features that are integral to the basic functionality, comfort, and delight of their occupants. As the dome reading room was vastly different without skylights, the other examples would also be completely different if their noted design features were removed. They would have less value if we took these integral features away. In order to design comfortable, low-energy, climatically responsive, and delightful interventions for heritage architecture, I think it is critical that the design team understand how the original architecture was meant to perform and how it was meant to be experienced. Decisions made with such an understanding can only enhance the functional, aesthetic, and symbolic value of heritage architecture. Thank you. Okay. Do we have time for questions, or should we just move on?
I think if we can take maybe one or two quick questions, but we're trying to kind of pull
that's
back
cool.
a little bit of time.
All right, that's fine. Yeah.
Yes.
I heard somewhere at the time when the metal covering of the dome was removed that it had been put on as a security measure for the Second World War. Are you aware of that?
No. As far as I read, and this is just through the library website pretty much, it was to avoid leaks. It was just leaking a lot, and they'd fix one leak in one place and then another one would spring up. But yeah, I don't know. It seems a bit late for the World War, no? Like 59? Yeah.
Okay, any other comment or question?
You know, in relation to Cairo Flats, the nature of the glazing that Best Overend used there?
I think it was plate glass. Is that what you mean? Or?
No, in the literature, it was referred to as Vita glass, and it was a glass that promoted your health and well-being. And I think it was through Wells Coates, Best Overend's associations with Wells Coates, but I prepared a conservation plan for the Port Authority building, and all the glazing in the Port Authority building has the little Vita glass stamp on it. But at the time, it was said that this glass was healthier than normal glass, and it was called Vita, Vita meaning life, of course.
Yeah, that sounds nice. And like marketing, yeah.
I'd have thought you might have picked that one up, because I think it was a critical element in the marketing of those little dog boxes.
Interesting.
They're the precursor of all the ones we're building on a much higher level now in Melbourne, as you realise.
I don't know that the glass from that time was anything that special. I think that was probably marketing. The thing with the way they were used in Cairo Flats, though, was that, well, of course I didn't have images of this, but the larger windows that were north-facing were capturing warmth and therefore promoting health. But it was how they were used, not what they were, I think.
I have a collection of literature on
Okay.
Vita glass as well. It was promoted as having, it was thicker than normal, and it was said to have a composition which trapped the heat and radiated it into the building interior during the winter and reflected it during the summer. And
if it's thicker, it would have more thermal mass.
Conceptual material. And McGrath, of course, in his book on glass in 1937, deals with that in great detail. But Best Overend was really at the vanguard as far as looking at thermal performance of glass and other materials there.
Issue, actually, if people want to find out the
story.
I should
Glass
look this up.
story.
That's great.
Thank you.
Okay, thank you, Noi. Okay, so thank you very much. Now, our next speaker this morning is Leon Yates. Leon is Urban Design and Heritage Advisor at the City of Port Phillip. He has many years' experience as an urban designer, heritage conservation project manager, and strategic land use planner. He's worked in strategic and statutory positions in both the private and public sectors in Australia and in the UK. And Leon's topic today is heritage and sustainability, policy and practice. Welcome, Leon.
Thanks, Justine. Thank you, and morning, everyone. I'd like to also thank Robert for extending his invitation to come and speak this morning. And this is a discussion that I've had and having regularly with the Heritage Council. So it's really good that we're all having this discussion, and I think it's really important that we continue to have it. My focus this morning is on policy and practice, and I guess at the coldface in many ways with the local environment, and dealing with a number of applicants and I guess a lot of the general public who aren't fully aware as to the benefits of these two things, i.e. heritage and environmental design. And I believe that they can coexist and that we can actually achieve much better design and much better heritage outcomes by approaching the two together. So clearly, and certainly the City of Port Phillip is seeking to balance these two issues. And obviously, as I said, there's the importance at the local level. At this level, much focus is on, as you can imagine, the aesthetic appearance of not just buildings themselves, but the context in which these buildings sit. And they range from, as you can imagine, in streetscapes and townscapes, very large to right down to your domestic residential accommodation. So you have to very much address the aesthetic and the context in which these issues have to be assessed. And what I'll do is seek to sort of review our policies in this approach, but also touching on and illustrating, I guess, some of the examples that I've certainly been involved in, and I think all of us may well have been involved in the course of our professions. So starting literally with the context of heritage and where policies sit, I guess, or what they're seeking to do is aiming to reflect the Borough Charter principles. And by its very nature, the Borough Charter, whether intentional or not, supports positive environmental design outcomes. Of the guiding tenets within the Borough Charter, two stand out, which is very much my focus today, as being consistent with environmental design. So it's understanding the fabric, but also doing as much as possible and as little as necessary. And to put that into some context, and I'm sure some of you would have had this experience as well, that quite often we'll see examples of, I guess the term I'll use is over-designed. In other words, there is clearly a good intention and a desire to come up with something, very, excellent in its design, but sometimes we can overdo it. And in my experience, that discussion, as I put it, is sometimes quite valuable, obviously, in bringing back, I guess, some of those issues to address what would then be, obviously a minimal sort of approach. And I'd be happy to continue that discussion, and I'm sure we will later on. So, for example, historic masonry buildings are an exceptionally durable and benefit to the significant thermal mass, and therefore preservation can often maximise the use of existing materials and infrastructure, reduce waste and preserve that historic character that clearly the policy is seeking to achieve. Just giving you some background as to, I guess, Port Phillip's approach and where we have sort of aimed and aiming to get to, and that will constantly be being looked at. And to give you some context of Port Phillip itself, a very large amount of the municipality is covered by heritage overlay, and therefore this issue is, a sort of definitive one in terms of certainly my experience in working with applicants and their designers. Council itself appreciates the need to address both of these, and has certainly in the last 10 or so years made a very strong commitment to working towards sustainable outcomes from the built environment. Council now have, started off with 2 dedicated advisors, and I work with a sustainable colleague in how we assess applications in this field. I guess the urban design and sustainability issues within the department have grown over time, and that sustainability team, which was quite small, as I said, about 10 to 12 years ago, is now consists of 17 staff, and that's across the whole sustainable. So I'm talking about sustainable transport planners as well. So approximately 75% of all our applications for planning permission tend to be alterations and additions. So we're dealing with existing housing stock, and there is a need to, clearly address today's regulations and make any new addition and alteration to an existing building as close to first rate as possible. The council, going back a good 6 or 7 years ago, has and needs to obviously address planning policy, and it's around about that time that Port Phillip embedded sustainable design within its heritage policy, and that is, as I said, a constant review and a need to upgrade, particularly as Robert illustrated. These things become outdated quite quickly, and we do need to keep addressing, are we sort of on track, and are we actually giving the right advice in terms of what can be achieved. So in Port Phillip's case, policy is to encourage environmental initiatives that will support the long-term sustainability of heritage fabric. We do seek to capture the resources in the existing fabric and retain it for its reuse. We're always looking to upgrade existing fabric to reduce operational and environmental impact of the existing building, but also to introduce new fabric, obviously in a heritage streetscape, predominantly to the rear, which achieves these sustainable outcomes whilst protecting heritage significance. And I will, through the course of this presentation, touch on some of those issues and illustrate as best I can. So dealing with the issues of objectives within the policy, we are seeking to provide for fair, orderly and economic sustainable use within the land, conserve and enhance those buildings and areas across the neighbourhoods, and we're looking at them in all of the issues of what the Charter addresses in terms of the cultural value and heritage value, seeking to balance and present clearly issues of today, but also seeking to address those futuristic issues that sometimes we are aware of but don't fully understand. So the Planning Authority, as the responsible authority, should seek to endeavour and integrate a range of policies relevant to the issues determined, and this is the key, I guess, from my perspective, and hopefully we'll bear this out in discussion further, is balancing these conflicting objectives, and it's no, I guess, surprise that often, particularly in planning schemes, objectives are absolutely conflicting, and you know, that's the need to work together to come out with the best outcome. So we do need to kind of have that discussion and focus on these sort of benefits, but also sustainable outcomes that, as I said, balance the two. So, just emphasising on what I think planning should be addressing, and there's a number of issues, as you know, in the approach to planning, but we do need to respond to the landscape. We need to value our built form, and we need to protect places and sites with that significant heritage. And I guess one of my focuses is, and I think we're all able to, I guess, have the discussion, is about the aesthetic. All buildings and engineering, subdivision and engineering works should include efficient use of resources and energy efficiency. So it is something that we do need to look at, and therefore, as I said, we do need to work collaboratively to achieve it. And one of the things we're seeking to do at Port Phillip is to promote the provision of new renewable energy in a manner that ensures appropriate siting and design considerations are met. I'll just touch on a graphic here which is kind of putting or illustrating where Port Phillip is trying to sit within this interesting debate, I guess, of heritage conservation and environmental conservation. I would say we are pretty much in the middle in many ways, but we are, and someone made a pretty interesting comment when I first showed this slide quite recently, and that is, it might be best illustrated in a sort of circular fashion, which I haven't got around to doing yet. But you can get an idea of what the sort of interesting issues that we're having to grapple with. So I'll quickly go through some of these 5 key issues within our heritage guidelines, and as I get towards the end, I'll show you some of the work that we're seeking to get out to the community. But just touching quickly on clearly the built envelope and how we take advantage of solar access, building fabric, and some of these elements within the heritage fabric that we clearly need to address, and we've heard some of the benefits of these elements, i.e. windows, the performance of the glazing. roof-mounted equipment, and this is one of the big issues in Port Phillip. And then this desire, certainly one relevant to Melbourne in its recent past, and I would say ongoing, to be honest, is the instalment of water tanks. So Port Phillip has developed internal sustainable heritage guidelines and to start with, obviously, our own planners, but also for applicants who are seeking to provide these improvements to their homes, but also to address the potential areas of conflict, which we have to grapple with in-house before we actually grapple with or seek to have that discussion with the community. So we developed, again, about 6 or 7 years ago, work with the Design Centre at RMIT and a number of professionals before my time at Port Phillip to see how we can address some of these issues and come up with guidance as best we can. So the intent for our guidelines is to provide standard heritage streetscape scenarios and see how best we can, as I said, balance the two. So developing our heritage, to develop a heritage dwelling which creates opportunities, we're seeking to capture the resources in the existing fabric and its retention for reuse. Again, addressing that fabric in order to reduce the operational environmental impact on the existing building. And as I said, in my experience, sometimes and quite often, it's about bringing back the discussion, if you like, and moving forward, I guess, in that collaborative fashion. So, just to give you some of the examples, sort of more recently, where we have this issue of the built envelope, so taking advantage of solar access. Here's an example in Port Phillip. I think it is. Sorry? I think this one might be. It's one slightly before my time. Sorry, is that? It's in Blessington Street, that particular one on the left you're talking about. Yes. Yeah. So yes, it's an example of the heritage fabric within Port Phillip, but how ideally to illustrate how you can actually retain that heritage character and accommodate for the new accommodation to the rear of the dwelling, maximising on a number of those sustainable issues. In this case, taking advantage of the solar access. Again, use of building fabric. Talana Hotel renovated not so long ago in Fitzroy Street, and again. The use of retaining built fabric, but bringing it up to today's standards, but equally hitting some of those sustainable benchmarks. Windows, and we've talked about performance of glazing. There are other things within the streetscape that can also assist, such as verandas. So they're all, I guess, something that needs to be assessed in that fashion. Moving on, here's the example of verandas and window restoration. And most recently, I had an application where they wanted to. They were happy to retain the windows, but and it wasn't a veranda as elaborate as this, but they actually wanted to remove it. And ironically, there was this concern that they weren't getting enough daylight, and it really was. It was again looking at how you could retain the veranda, but sort of improve the lighting within the building. And then the one that is I'll touch on very, very briefly later, but very soon, is this issue of solar panels. And you know, clearly this is one of Port Phillip's greatest, I guess, percentage of applications. It's solar panels that we're receiving a number of applications for, but on a lot of heritage buildings within the municipality. And then I probably should have swapped these two slides around. But then, as I mentioned earlier, water tanks. And the issue here was actually siting of the water tank. Some properties are just difficult to, I guess, screen them or hide them, and particularly a corner property. The example here was where they actually wanted to stick it right on the veranda or in the front garden, and we actually worked with them to find a better location. And then now, just quickly, I'll use just illustrating the case study within Garden City Estate, Port Melbourne, a listed estate, one of Melbourne's first historic estates, public housing of significant importance in Victoria's history, and given the layout and design of the practice at the time, is one that was really important to protect and conserve. Part of the design element or characteristic is hipped roofs and gabled roofs with terracotta tiling, those being key to that fabric. But then how do you address a resident who wants to put solar panels on a house in an estate of such importance? Again, issue of orientation. Not all roof slopes face the sun, and the sun moves. So, quite frankly, it is difficult. But again, with I guess assessment and again this ongoing discussion, it can be achieved. So the example here is the one on the left is the very first application, and this again goes back to some of the issues of time that Robert touched on. And this is 2 years ago when the first application came in. It was 46 panels on the northern slope, which was the street-facing slope. So, you know, when you assess something like this, does 46 panels on a roof slope alter or impact on the heritage significance? Pretty obvious answer. So we worked with the applicant to look at another system, and ironically, by the time this application came in, whilst we're having this discussion, this particular manufacturer stopped making this type of panel. So the applicant themselves had to find another manufacturer. The other manufacturer came up with a slightly different panel, less in sort of quantity, and even addressed or I guess in his assessment was addressing the need in this case to put it on both slopes of the roof, illustrated on the right hand side. Now, council, and then the last iteration, so it came in a third time, was it had actually gone from a bit less to now a bit more, but not as much as before. So it was going all over the place. Having said that, what we, and with our sustainable development team, sought to address with this particular applicant was actually other ways of improving energy efficiency in the home. So he saw solar panels as the sole factor for him on addressing energy. And we actually said there are a number of other things you could do, and we'll work with you to achieve that, and therefore minimise the amount of panels you may need, and then place them in I guess, not logical locations, but more suitable locations that would address the heritage policy as well. Sadly, he didn't take that on board. He never got refused his application, but he had a condition, which meant he couldn't put it on the street-facing roof slope. He took us to VCAT and argued that a panel should be seen similarly to a TV aerial, which VCAT, the member decided, I'm sorry, I'm just not going to do that, and unless the planning scheme puts solar panels in the same list as satellite dishes and TV aerials, he wasn't going to entertain that argument. So subsequently, he got a permit for solar panels, but just not as many, and in the location that he proposed. He's now seeking to take us to a higher court on human rights issues. So that's something we could talk about later if you like. Having said that, you know, it's important to place these things in appropriate locations. And it's not to say they cannot or should not be visible from the street. It's really about how you minimise the impacts. And here are two examples of you know, certainly panels visible from the street. And the image on the left, you could argue, you know, maybe they could have pushed it slightly further back, maybe in line with the chimney. And the one on the right, I believe, has actually achieved a good location, and hence the efficiency required. So just to wrap up, some of the key factors, and I won't sort of read through them, but we approach it in a place and high-quality streetscape approach. And we also are very mindful of meeting these environmental design issues. Just to quickly illustrate the sort of guidance that we're seeking to produce for the general public and the community, just to kind of have that conversation as to where the best location might be. And I've just illustrated the one for panels, solar panels. We have a range of these fact sheets dealing with a number of those other elements that I illustrated earlier. We also produce a number of fact sheets to do with SADAP, and we've been working in the IMAP Council, which is Melbourne's inner urban councils, to come up with a sort of guidance that is relevant to all councils. After all, council boundaries are, you know, lines on a map, but our urban environment and inner urban Melbourne is seen as one sort of significant part of Melbourne and Victoria's heritage. And just finally, sort of some of the key messages in terms of addressing these issues, and how we at Port Phillip sort of seek to overcome and work together to achieve them. Thank you.
Very ably illustrated the tensions that one negotiates in these situations, and I'm sure there'll be very fertile ground for discussion. But right now we're going to move straight on to Craig Langston. So again, just keep all your questions and comments, and we'll really try and have quite an interactive discussion at the end, I think. So Craig is our last speaker in this morning's session. He's Professor of Construction and Facilities Management at the Institute of Sustainable Development and Architecture at Bond University. Craig's work spans issues of sustainable development, building adaptation, multi-criteria decision-making, one of the topics of Leon's talk, and construction performance. He's the author of 5 books and has completed 4 ARC Research Council funded, ARC-funded research projects. Craig's topic today is Green Adaptive Reuse, Enviro Heritage. So, please welcome Craig.
Well, good morning, everyone. I'm Craig, and I'm from Queensland. As you can probably gather, I've got the sunglasses and the jumper coming down to Melbourne, so I should get rid of all of these things, and I'll try and be a Melbourneite for just a few minutes. I don't, but I'm thinking you might. Yes, my talk, as Justine mentioned, is on green adaptive reuse, which many of you might say, well, isn't all adaptive reuse green? And I think the answer is yes. But the tension in my talk is really about how we can improve work on existing buildings and heritage-listed buildings by incorporating environmental performance as part of that adaptation. So green adaptive reuse is a term I've coined really just to highlight the fact that environmental performance and adaptive reuse are not mutually exclusive. Okay, so I did a little analysis on the LEED directory of projects that have been certified as platinum in the US. Now, platinum is really the equivalent of our Green Star 6-star in Australia. And what I found, a little bit to my surprise, was that only 5% of projects that have been approved as platinum are adaptive reuse projects. And the remainder are either renovations to projects that are the same function or, in fact, new buildings. Now, this morning, just to get the latest data, I went to the Green Building Council of Australia website and I did a search on 6-star buildings in Australia, and there's 42 of them that are office type certified for office design, and 2 of those are existing buildings. So again, it's about 5%. So it led me to the initial question of, are our green rating schemes biased against heritage work? Why is it that such a small proportion of buildings are certified at those highest levels? But the research question I'm going to use in today's talk is really whether these heritage conservation opportunities and high-performance green project opportunities are mutually exclusive, or are they just rarely witnessed? So I'm going to use a case study today. Now, I was born in Sydney and worked a long time in Sydney, and this is a Sydney case study, even though I have lived in Melbourne for a bit and now in Queensland, so a bit all over the place. But this is a project you're probably aware of. It's in the Rocks area of Sydney at 88 George Street. And the background of all these slides actually is the building that I'm talking about here. So this project, it's now 128 years old. It was adaptively reused from an industrial warehouse and I guess almost like a factory usage to an office building usage in 2010. It was the first heritage listed building of its type to receive a 5-star Green Star rating. I'll talk more about some other ones, other projects shortly in other parts of the country that are similar, but this was the first one. So here are some photographs of the building from the architect's website, and you can see instantly that the building is in a very good location. It has views of the Opera House in Sydney and the Harbour Bridge. It sits pretty much on the foreshore of Sydney Harbour. It has beautiful windows and fenestrations to the views and capturing natural light, natural ventilation opportunities, etc. And as Robert pointed out in his talk earlier, there's a lot to be gained from adaptive reuse when we look at existing buildings over new buildings, and this would be a great example of that as well. So adaptive reuse means a significant change in function. So that's its definition. So what we're looking at is taking an industrial building and converting it to an office building or to some other, quite different function from what it started on. And it can extend the useful life of the building when that happens, assuming that the existing function had become obsolete. Rather than knock the building down or leave it derelict if it's protected and no one wants it, is actually how can we give it new life through a change in function. So I've been working on a number of models over the years, and I'm going to talk about 3 of them briefly today. The first one is called the ARP model, or Adaptive Reuse Potential Model. What it does is it ranks the potential for adaptive reuse in existing buildings and identifies the optimum time when you should intervene to change function. It works on a principle which a lot of you, I'm sure, would be aware of, that buildings should have long life, loose fit and low energy as principles of their design. And the way the model works is useful life is defined as discounted physical life, much like a discounted cash flow might convert money from one point in time to another. And it uses an estimated rate of obsolescence as the discount rate. So here's the worksheet of the ARP model, and you can see a number of things there. Well, probably, depending on how good your eyesight is, you may not be able to see all of the things there. But if I can perhaps just quickly draw your attention to the fact that, I just need to... Okay, just draw your attention to the fact that it forecasts the life of the building in this model, and the answer it comes up with is 200 years of life. This study was done when it was just around about 120 odd years of life, so it had potentially 40% of its life left. And that's worked out on a simple, well, not so simple actually, it's a bit of expertise built into what looks like a simple calculation where you answer yes or no to a series of questions and it tells you the answer. I'd have to spend a bit more time than I have to explain how that works. But nevertheless, once you have that, it then calculates an obsolescence rate, which comes from these areas here. So there are 7 obsolescence categories, which are scored. Oh, that was unfortunate. Good. And it comes up with an adaptive reuse potential score, in this case 75.1. And this is how it's displayed graphically. This graph shows a decay curve following this line here. And over a period of life, which is presented as a percentage, adaptive reuse potential grows until it reaches the point where obsolescence is predicted, and then potential declines until the end of its life. So this particular graph, this particular graph explains that this actual intervention occurred at the right time, almost perfectly, and so the adaptive reuse potential was optimised in this particular project. But many other projects, of course, are not so well coordinated. The second model I want to talk about is called I Concur, and actually I've worked with an excellent group of people, including Robert Crawford, on this project over the last 3 or 4 years. And we've just finished our conclusions on that in the last few months, actually. So I Concur is a 3D model, a bit like a cube, if you imagine a cube, that has an X, Y and Z axes. X means the condition of the building, Y means the utilisation of the space within the building, and Z means the reward, triple bottom line reward that comes from the building upon its completion. So this model is useful to be able to judge and compare different choices one has in adapting existing buildings. So this is the model of I Concur. It's just another seemingly simple spreadsheet model, but a little bit going on in the background. But if you notice the graphic up here in the top right-hand corner, this is the base of the cube, and it shows that there are 4 corners of that base. One is to reconstruct or dispose of your asset, which is this area down here. Gotta be careful. Another is to renovate and preserve, retain and extend, and be careful, and reuse and adapt. And on this particular project, this X that's shown here is the position of the coordinates after it was assessed. This was before the intervention. And the distance of that point to the nearest corner tells you what you should do. So in this case, it was saying this building is suitable for reuse. And the actual distance of that X to that corner can be measured and used to rank various projects in terms of which one has more potential for that action than the others. Also, we can look at things like the various stakeholders involved in the project and whether they have short-term, medium-term, long-term. There's a lot of analysis that can come from this model by digging down and thinking about it further. And after the intervention, the calculation was repeated again. And you can see that the X moved from somewhere around here to here, which has moved it closer to the retain extend corner of the model, which indicates that we've actually made this asset something that we want to keep, whereas before it was perhaps something that needed work. So the score went up, I think, from 2 point something or other to 3.32 as a result of that. Now, this slide here, if you can imagine, is a little video of the I Concur model, which my faithful assistant here is about to display for you. So it's a 3D model, 5 by 5 by 5 cube, and you can see there that there are 2, I've made them very large dots in the model. One was the before and one was the after. So as a result of the intervention, adaptive reuse, the project improved its status and moved higher towards the retain, extend side of the cube. The higher up in the cube it is, the more valuable the project has become. So you'd want to make sure that after your intervention, the thing that you've left with is higher up in altitude in the cube than the thing you started with. And also that it's closer to the correct corner to maintain and keep. Thank you very much. That was excellent. The model also enables risk to be calculated, and when you look at the model on a 2D basis, the distance, and you can see here where the points, you can see here this was the before and this is the after, and the distance that these points are to the hotspot corners dictates what you should do, as I mentioned before, and also the distance from the centre of the model indicates the level of risk attached to that decision. So something that's near the centre has high risk attached to it because you're not sure which direction it might go in. In fact, right in the very centre, of course, it's torn amongst all 4 corners. But as it gets closer and closer to a corner, its risk decreases because you're more confident about what you should do with it. The third model I'd like to briefly talk about is called Syndex, and it's something I was working on back in the days when I used to work with Robert at Deakin Uni down here in Victoria. So Syndex is a multi-criteria model that takes 4 key characteristics of projects, as shown there on the screen: to maximise wealth, to maximise utility, to minimise resources, whether they be embodied resources or operating resources, and to minimise impact on our environment. This model is actually freely available to anyone who wants it, so I can send it to you if you're interested. It's a little standalone application that has the 4 criteria shown on the screen there. And you can click on these boxes here, and it opens up further windows where you enter some fairly simple information, actually, and it calculates a score. And the score is shown here at 3.49, which is quite a high score for this case study project. And this little control here, you can move this slide. I can't do it because it's a graphic, but you can move this lever towards an economic side or a social side, and it will then maximise the wealth and resources if it's economic, or it will focus on utility and impact if it's social. But I always put it in the middle. And as that moves, it would be really nice to do it, the face changes. It goes from smiley or happy to actually crying. So what you want is a happy face, and you want a score that's, reasonably high. 3.5 is a good score. So this project was a good decision. So I think that's the reason I'm talking about it today, is because it was a successful project. But I've looked at it in hindsight. I wasn't involved in the decision process, but I think they made a good decision. But not all are like that, of course. So in conclusion, I've come to the conclusion that sometimes the greenest buildings are the ones that we already have, and that's not really my statement. That was said many years ago by someone much more famous than me. But what I've learnt is that combining adaptation with green retrofitting adds value and helps to preserve important heritage attributes. And this case study, although I haven't had a lot of time to talk about it, was full of a number of environmental performance initiatives, and that earned it a 5-star Green Star rating, and it was the first in Australia to get that level rating. So it's about as green as a heritage building. Well, it was as green as anything in 2010, never been done before in this country. So that's what I mean by green adaptive reuse, not just adaptive reuse, but also environmentally superior adaptive reuse. And that's what I call green adaptive reuse, or also enviro-heritage, which I've just a new thought, just for today's conference. I thought I would throw that one out there for you to see whether it's something you want to take and run with, because I think it's rather catchy. So this presentation has demonstrated that adaptive reuse and exemplar environmental performance are not mutually exclusive. They're still rare, but they can happen. And ensuring heritage-listed projects are fairly treated by green rating tools, such as Green Star or LEED, probably does require further inquiry, and it's not something I'm really capable of doing. But experts in how the rating tools work might need to have a look and just see whether they're biasing towards new construction. I suspect that they are on the percentages, but how you fix that is someone else's problem. There are several other heritage buildings now that have been awarded 5- and 6-star ratings by Green Building Council of Australia. I think Evelyn is going to talk about one of those after morning tea, is that right? The Good Shed North is a 5-star Green Star building first in Victoria for heritage. Yes, excellent. And in Sydney, for those of you who are a little bit aware of outside of Victoria, there's 39 Hunter Street, which is a 6-star heritage building. Well, 6-star Green Star heritage listed reuse. Well, it's an adaptation. I wouldn't call it an adaptive reuse because it was an office building and it still is an office building, but it's close enough. So let's say that's a 6-star. And there's also Legion House in Sydney, which might be foreign to you, pun intended. But Legion House is a carbon neutral building and is a real adaptive reuse building as well, and it's just been finished. So on my case study, these are the key design team members. And if you want more information on green adaptive reuse, I would refer you to a paper I wrote a year or so ago called Green Adaptive Reuse Issues and Strategies for the Built Environment, which is available from Springer online. And if you want to know more about the models, which I didn't tell you enough to be useful, I suppose, today, but they're all written up in this book coming out in a few months called Sustainable Building Adaptation, Innovations in Decision Making by Wiley and Blackwell. It should be out in February next year. Thank you very much.